Hello math fans, here's a series and we'd like to test to see if it's absolutely convergent, conditionally convergent, or divergent. The first thing to notice is that there's a factorial in it, which leads us to try to use the ratio test. Anytime you see factorials, you should be using the ratio test. There's an exponential in here. I want to think of n to the n as being an exponential function. That also is useful, the ratio test is useful for, but really it's the factorial that leads us to the ratio test. The other thing to notice is that this series has positive terms, so we don't need to use the absolute values in the ratio test. So we're going to compute the limit as n goes to infinity of a sub n plus 1 over a sub n. Okay, so that's what we have here. So notice that the numerator there, the n plus 1 factorial over n plus 1 to the n plus 1, that's just this thing here, but with an n plus 1 everywhere you see the n. Okay? And so we have a sub n plus 1 over a sub n. So now we're going to try to simplify this. And so instead of having a fraction over a fraction, let's flip the denominator upside down and rewrite it like this. Okay, so let's reshuffle this so that the factorials are together and the power functions, or the exponential functions, are together. So it's going to look like this. So now let's think about factoring this piece here, or doing some canceling. You should notice the way we want to think about this is that n plus 1 factorial is just 1 times 2 times 3 all the way out to n plus 1, whereas the denominator is just 1 times 2 times 3 all the way out to n. So when you cancel, what you are left with is just an n plus 1 in the top. If you have a hard time seeing that, then you need to write out those factorials. Okay, so now let's pay attention to see about canceling out this in the second piece over here. Okay. So first let's break things up. Let's take that denominator, that's n plus 1 raised to the n plus 1 power, and let's rewrite it like this. So that there's an n plus 1 to the n and an n plus 1. So now we can actually do some really easy canceling, because that cancels with that, right? And so those are gone, and we're just left with the n to the n over n plus 1 to the n. Okay, so now let's combine that into a single power, right? Because both the numerator and the denominator have a power of n, so that we can rewrite it with the fraction on the inside. And now by doing a little bit of rearranging, if I flip that thing inside, upside down, I can turn it into n plus 1 over n raised to the negative n power. And the reason I want to do that is because now on the inside, if you notice, the inside looks like 1 plus 1 over n. And now this is a limit that you should recognize, and it turns out that this is e to the minus 1. So I'll show you the form of the limit that you need to recognize in a minute. Okay, so since this is our final calculation out of the ratio test, then we can say that since this number is less than 1, the series converges absolutely by the ratio test. Now let's talk a little bit about this limit and how we know that how do we know that that comes out to e to the negative 1? Okay, so what I'm using is this useful fact, that if you have a limit as x goes to infinity of 1 plus a over x raised to the bx power, that's always equal to e to the ab. So in this expression here, I'm using a equals 1, b equals negative 1, and so that's how we end up with e to the negative 1. This limit down here, the way you would evaluate that is using L'Hopital's rule, and so that'll be a calculation for another time. Okay, that's it for Math Fun now. Talk to you later.